Okay, guys. So this video is about uh, another question based on the same Cantor's diagonalization argument. So this is to prove that the set of real numbers are. This is to prove that the set of real numbers are uncountably infinite. So we already know that the numbers like integers are infinite. There are infinitely many integers, infinitely many rational numbers, and so real numbers are also there are infinitely many real numbers. But to prove that they are uncountable, so what we are actually trying to prove is that if we list down all the real numbers that we have, and if we like map each real number to a natural number, then we have to prove that we miss some like we can't find we will miss to map some real number in the list of all the real numbers that we have listed, right? So, what that means is like, let's take only just for this proof, we will just consider the interval between 0 and 1. So, if there are infinitely many uncountable real numbers in this range, then that's also the proof for the fact that there are uncountably many infinite real numbers, right? The type of type of proof that we use to in this question is like proof by contradiction, right? So in proof by contradiction, what we'll assume is that real numbers are countably infinite. So that will be our assumption, and then what we say is if real numbers are countable, like we are talking about this interval between 0 and 1. So if the real numbers between 0 and 1 are countable, we should be able to list down all the real numbers that are between 0 and 1. So let's say we have that listing and so we say that's like 0 dot point a1, a2, a3, right? Or let me call it a11, a12, a13, dot dot dot. Then the next real number is 0.A21, 22, 23. So these A11, A12, A13 are all the digits after the decimal point. So the first one means that's the first number, and the second one means that it is the first digit of the first number, right? So this 2 will mean that that's the second decimal digit of the first number, right? So like that. So according to the assumption that we have made, we'll be able to list down all the real numbers that are there like this. Now A31, A32, A33, it keeps going. So now what Cantor does is he makes an argument uh, for all the digits along the diagonal of these real numbers that we have listed. So if you look at this diagonal, right? So we find elements of the form uh, A11, A22, A33. Now Cantor goes on to make a new number, right? So that what that new number is. So he argues like this. So that new number will look like it's between 0 and 1. So it's going to look like 0.B1, B2, B3, B4, dot dot dot. So what he does is we'll choose the digits B1, B2, B3, B4, etc. in such a way that AII is not equal to BI, right? That means this first digit B1, right? That will not be the same as A1, right? Similarly, the second digit B2 that will not be the same as B2. So if we have listed down all the real numbers there are, and now if I like form a new real number, like by changing each of these digits along the diagonal, so this new number is going to be different from all the other real numbers that we have listed, because uh, one digit in each real number we have listed is different in the new real number that we have found, right? Like it for the first real, A11 is not the same as B1, and A22 is not the same as B2, A33 is not the same as B3. So the number that we create is going to be different from all the numbers that you've listed. So which means that we have now got a digit which is different from all these numbers, which means we missed this digit, right? We said we were able to list all the real numbers, and then now we are saying that there is one digit here which is not part of that list, which means uh, we failed to list all the real numbers. So that proves that the set of real numbers are uncountably infinite, and that's the proof for that.